There is an object in the universe so massive it breaks the imagination. It is a black hole, but calling it a black hole is like calling the ocean a puddle. It weighs as much as 66 billion suns, not one sun, 66 billion. Its edge is so wide that light itself needs weeks just to cross it. It swallowed a mass of stars so vast we can barely write the number down. And it shines as it feeds with the light of 100 trillion suns. We can see it from 10 billion light years away, from almost the dawn of time. Its name is Ton 618. And it is one of the largest things ever discovered. To understand it, you first have to understand what a black hole really is. A place where gravity wins so completely that not even light can escape. Welcome, you're watching To the Moon and Back. Here we travel to the real places science has found in the dark. Today, the monster at the edge of physics, and what it would do to you. Let's fall toward a hole in the universe. Gravity is the gentlest force in the universe. It also never, ever stops. Every object with mass pulls on everything around it: Earth, the sun, you. To escape a planet's pull, you have to move fast enough, and escape speed. From Earth, that speed is about 11 kilometers a second, fast but possible. The more mass you pack into a small space, the higher that escape speed climbs. Now squeeze a giant star into a tiny ball. The escape speed keeps rising. Until at some point, the escape speed reaches the speed of light itself. And nothing in the universe travels faster than light, nothing. So at that point, not even light can get out. The object turns black. That is a black hole, a place where gravity has sealed itself off from the universe. The boundary of no return has a name: the event horizon. Cross it and you can never come back, not even light can turn around. The event horizon is not a surface, it is not solid, you would feel nothing crossing it. It is simply a line in space beyond which the future leads only inward. Inside, all paths lead to the center, toward a point we barely understand. A place where our physics breaks down completely, the singularity. A point of infinite density, where the rules simply stop making sense. We do not know what truly lies there. It may be the deepest mystery in science. But black holes are not empty voids that just sit in the dark. When gas and stars fall toward one, they do not drop straight in. They swirl around it faster and faster, forming a flattened, blazing disk. This is the accretion disk, and it is one of the brightest things in the universe. Squeezed and sheared, the gas heats to millions of degrees and blazes with light. So a black hole, the darkest object there is often ringed in brilliant fire. And its gravity is so strong it bends that light into a halo, over the top and under. That eerie, glowing ring is not science fiction. It is exactly what we would see. For decades, black holes were just mathematics, a strange solution in Einstein's equations. Einstein himself doubted they could really exist, they seemed too extreme. But the universe, it turns out, is full of them. The first hints came from stars behaving strangely. Astronomers found stars whipping around something massive and utterly invisible. Something with the mass of many suns, packed into a space smaller than a city. Only a black hole could do that. The evidence piled up year after year. At the heart of our own galaxy, they found something enormous. Stars there orbit an invisible point at a fraction of the speed of light. The thing they circle weighs 4 million suns, our galaxy's central black hole. For years, we could only infer it. We had never actually seen a black hole. Then in 2019, that changed forever. Astronomers linked telescopes across the whole planet into one Earth-sized eye. And they aimed it at a giant galaxy called M87, 55 million light-years away. They captured the first real image of a black hole's shadow. A dark circle ringed by a glowing halo of bent light, exactly as predicted. A century of theory confirmed in a single blurry, world-changing picture. That black hole weighs 6.5 billion suns, and it was not even the biggest. A few years later, they imaged the one at the center of our own galaxy too. Proof in a photograph that these monsters are real and near. But the black hole in M87 fires something even more spectacular into space. A jet of plasma blasting outward at nearly the speed of light, stretching thousands of light years, longer than the galaxy is wide. These jets are how the biggest black holes announce themselves across the universe. When a supermassive black hole feeds hungrily, it becomes a quasar. The most luminous, most violent objects in the entire cosmos. As gas spirals in, friction heats the disk until it outshines a whole galaxy. A single quasar can shine brighter than 100 billion stars combined. Bright enough to see clear across the observable universe. Because they are so far away, we see quasars as they were billions of years ago. Their light left before the Earth or even the Sun existed. Looking at a distant quasar is looking back into the deep past of the universe. And the brightest of them are powered by the largest black holes of all. Which brings us at last back to the monster we started with. Ton 618, a quasar so bright it was spotted decades ago as a strange blue star. It turned out to be no star at all, but a black hole 10 billion light-years away, feeding so ferociously that it blazes with the light of 100 trillion suns. From its brightness, astronomers weighed the black hole at its heart. 66 billion times the mass of our Sun, among the largest ever measured. Its event horizon is so vast, it dwarfs our entire solar system. Light, the fastest thing there is, would take weeks to cross it from side to side. If it replaced our Sun, its edge would swallow every planet and reach far beyond. It is not just a big black hole, it is a black hole the size of a solar system. And it grew that large within the first few billion years of the universe. Which is a genuine mystery. There may not have been enough time to grow so huge. How these giants formed so fast, so early, we still cannot fully explain. They are monsters whose birth we do not yet understand. But we do understand in chilling detail what they do to anything that comes close. So let's do the unthinkable, let's fall in. Not into a monster like Ton 618, into an ordinary black hole a few times the Sun. From far away it looks small, a dark dot ringed with glowing gas. As you fall closer, its gravity grips you, and time itself begins to bend. Near a black hole, time slows down. This is not a trick, it is real physics. To someone watching from a safe distance, you appear to fall slower and slower. Your image reddens, dims, and seems to freeze forever at the edge. But from your point of view, time feels perfectly normal. You keep falling. And as you fall, gravity pulls harder on your feet than on your head. Near a small black hole, that difference is monstrous. It stretches you. Scientists gave this a grimly perfect name: spaghettification. You would be pulled into a thin stream of atoms before you ever reach the center. Strangely, near a giant like Ton 618, the fall would be gentler at first. The bigger the black hole, the weaker the stretching at the edge. You could cross the horizon of a giant for a while and feel almost nothing. But there would be no way back. The universe outside would be gone forever. And if you looked back out as you fell, you would see something astonishing. The entire history of the universe playing out faster and faster behind you. You would watch the future of the cosmos unfold in your final moments. What lies at the very center, no one knows. Our physics cannot follow you there. It is the one place in the universe from which no information ever returns. A stellar black hole would tear you apart, a giant would swallow you whole. Either way, you become part of the darkest object in existence. But black holes are not only destroyers, they are also builders. Almost every large galaxy has a supermassive black hole at its heart. Ours does, so does Andromeda, so does nearly every galaxy we have ever studied. And astonishingly, the black hole and its galaxy seem to grow up together. The bigger the galaxy, the bigger its central black hole, always in step. As if the monster in the middle helps shape the galaxy around it. Their jets and winds push gas around, starting and stopping the birth of stars. A black hole can heat a galaxy's gas and shut down its star formation entirely. Or, in gentler times, allow whole new generations of stars to form. The darkness at the center helps decide what the light around it becomes. Without these monsters, galaxies like our own might look nothing like they do. The black hole is not a hole in the galaxy, it is the anchor the galaxy is built around. And the largest of them, like Ton 618, anchor the largest galaxies of all. Titanic black holes at the center of titanic collections of stars. When two galaxies collide, their central black holes eventually find each other. They spiral inward and merge, sending ripples through space itself. Ripples we can now detect on Earth as gravitational waves. The shudder of two black holes becoming one, felt across 1 billion light-years. This is how the giants grow, by feeding and by merging over cosmic time. Building over billions of years toward monsters like the one we began with. Ton 618 blazing across 10 billion light-years at the dawn of the cosmos. A black hole the size of a solar system, with the light of 100 trillion suns. A reminder of just how extreme the real universe can be. Black holes sit at the very edge of what physics can describe. They are where gravity, space, and time are pushed to their absolute limits. Studying them is how we test our deepest ideas about reality. Every image, every gravitational wave, every quasar teaches us something new. And every answer opens a deeper question. What is inside? What are they truly? We have photographed their shadows, we have felt their collisions. But the singularity at the center still hides from all our physics. To crack it, we may need a whole new theory of the universe. Black holes are not just objects, they are the questions the universe asks of us. And the biggest of them all, Ton 618, asks the biggest question. How did the universe build something so vast, so soon after it began? We do not yet know, but we are learning, one photograph at a time. Somewhere out there right now, Ton 618 is still feeding, still blazing. Its light, 10 billion years old, is only now reaching our telescopes. A message from the deep past, from the largest thing we have ever seen. The universe is not gentle, and it is stranger than any story we could invent. Monsters of gravity, anchoring galaxies, bending time at the edge of the knowable. All of it real, all of it out there, all of it waiting to be understood. If that broke your brain a little, then you belong here. This channel is a map of the strangest real places in the cosmos. Subscribe, and every week we travel somewhere no human will ever stand. Tell me in the comments, would you fall into a black hole if you could watch the universe end? There is so much more dark out there, and so much more to find. Thanks for watching To the Moon and Back. Keep looking up.